Given that cot inverse of 3x plus 5 is greater than pi by 4, then we need to find the range of the values of x. So here we can also write cot inverse of 3x plus 5 is greater than cot inverse of 1. Since cot pi by 4 is 1, so pi by 4 we can write it as cot inverse of 1. Let's see the graph of cot inverse of x. The range is 0 to pi. And the graph we can see the graph lies between 0 and pi. It's a decreasing function in 0 to, here let us consider 1. 0 to when the graph is decreasing, or for all positive values, for every cot inverse x is decreasing we can say. And hence we can write, since x lies between 0 and 1, cot inverse of x, and here cot inverse of 0 is greater than cot inverse of x is greater than cot inverse of 1. So for x less than 1, cot inverse of x is greater than cot inverse of 1. So cot inverse of 3x plus 5 is greater than cot inverse of 1. So we can write 3x plus 5 should be smaller than 1. That is 3x is less than 1 minus 5. 3x is less than minus 4. So x is less than minus 4 upon 3. So therefore the range of values of x, the range of the values of x can be taken as minus infinity to minus 4 by 3. So this is the answer. Given that the cost of producing x items in a factory each day is given by C of x is equal to 0.00013 x power 3 plus 0.002 x square plus 5x plus 2200. We need to find the marginal cost when 150 items are produced. So we know that the marginal cost is change in production, change in the production cost with respect to the number of items produced. So here it is given production cost as C and the number of items is X. So which means we need to find dC by dx when 150 items are produced, that is X is equal to 150. So we need to find this. Let's differentiate the function C. So given C of X is equal to 0.00013 x cube plus 0.002 x square plus 5x plus 2200, and now differentiating C dash of x, that is dC by dx is equal to, so here we can write 3x square differentiation of x power 3, so 0.00039 x square, and here x square differentiation 2x, so 0.004x, and differentiation of x is 1, so 5 plus 2000, differentiation of constant is 0, which is equal to, and now we need to find at 150 items, so C dash of 150 is equal to 0.00039 into 150 square plus 0.004 into 150 plus 5, and after simplification and calculation you will get 8.775, and here 0.6 and 5, so adding you will be getting 14.375. So we can go with an answer. The marginal cost is nothing but rupees 14.375. This is the answer. we need to find the derivative of tan inverse of x with respect to log x, where x belongs to 1 comma infinity. So tan inverse x and log x both are defined. So we need to find differentiation of tan inverse of x. Let us consider this is f, and log x, let us consider this is g. So we need to find df by dg. So which can also be written df by dx divided by dg by dx. So let f of x is equal to tan inverse of x. So differentiating df by dx is equal to 1 upon 1 plus x square, tan inverse x differentiation. And similarly g of x is equal to log x for x is greater than 1, and g dash of x, that is dg by dx, is equal to 1 upon x. Now df by dg is equal to df by dx upon dg by dx, that is 1 upon 1 plus x square divided by 1 upon x. So we can add x upon 1 plus x square is the answer. We need to differentiate the function cos x to the power of x with respect to x, where x belongs to 0 comma pi by 2. So let us consider a y is equal to cos x to the power of whole to the power x. Apply log on both the sides. Apply logarithm to the base e on both the sides. So we get log y is equal to log of cos x whole power x, which can also be written log y is equal to x into log of cos x. Now differentiating with respect to x. So differentiation of log y is 1 upon y into dy by dx. And here let us apply UV rule. UV whole dash is equal to u into v dash plus v into u dash. So we can get x into differentiation of log is 1 upon cos x into again differentiation of cos is minus sin x plus log of cos x into differentiation of x is 1. So we can also write dy by dx is equal to, so here y into x times of sin x upon cos x is tan x, so minus x tan x, and here log of cos x. This can also be written what is y? Cos x whole power x, so we can add cos x whole power x into log of cos x minus x into tan x is the answer. Given vectors a is equal to 2i plus 2j plus 3k, and vector b is equal to minus I plus 2j plus k, and vector c is equal to 3i plus j plus 0k. And these vectors are given such a way that b plus lambda c is perpendicular to a for some lambda belongs to r, some scalar. So let us consider b plus lambda c. B plus lambda c is equal to minus I plus 2j plus k plus lambda times of vector c, that is 3i plus j plus 0k. So we get which is equal to minus 1 plus 3 lambda of I, 2 plus lambda of j, 1 plus 0 lambda, that is 1 plus 0 lambda, of k. And now this vector is perpendicular to given b plus lambda c vector is perpendicular to vector A, which implies that b plus lambda c dot product with A, since they are perpendicular, dot product will be 0 since cos 90 is 0. So here we can write minus 1 plus 3 lambda of I, 2 plus lambda of j, 1 plus 0 lambda of k, dot product with vector A, that is 2i plus 2j plus 3k is equal to 0. So that minus 1 plus 3 lambda into 2 plus 2 plus lambda of 2 plus 1 into 3 is equal to 0. So we can write here minus 2 plus 6 lambda, 2 to the 4 plus 2 lambda plus 3 is equal to 0, or we can write 8 lambda, 4 plus 3 7, 7 minus 2 is 5 is equal to 0. So lambda is equal to minus 5 by 8. So minus 5 by 8, some real number, some constant. This is the answer. Given that a person standing at origin 0 comma 0 comma 0, let's consider the coordinate axis plane, x axis, y axis and z axis. So origin is the point here, it's given O, and is watching an aeroplane which is at the coordinate point a4 comma 0 comma 3. So we can mark 4 units on x axis and 0 on y axis and 3 units along the z axis. So I can consider here this is the point A 4 comma 0 comma 3. At the same time he saw a bird at the coordinate point 0 comma 0 comma 1, which is at the z axis. So 0 comma 0 comma 1, say this is the point B, and now we need to find the angles which the BA vector makes with the x axis, y axis and z axis. Means we need to find the direction cosines of the vector with respect to the coordinate axis. So let's find the BA vector. Since OA is equal to, we can write 4i plus 0j plus 3k vector, and OB is equal to OB vector can be taken as 0i plus 0j plus 1k. Now the vector ABA is equal to, we can write OB vector OA vector minus OA vector minus OB vector. So OA is 4, so 4 minus 0, that is 4i plus 0j plus 3 minus 1, that is 2k. So since the vectors having the direction ratios of vector BA can be taken as ABC given by 4 comma 0 comma 2. So this can also be taken by the ratios by taking 2 common, 2 comma 0 comma 1. So they are ABC, and direction cosines L comma M comma N, we can find L is equal to A upon root of A square plus B square plus C square. So we can write here 2 upon 2 upon root of 2 square plus 0 square plus 1 square, that is 2 upon root 5. Similarly, m is equal to 0 upon, that is 0, and n is equal to 1 upon root of 2 square plus 0 square plus 1 square is root 5. So L value is 2 upon root 5, M value is 0, and N value is 1 upon root 5. And we know that if alpha, beta and gamma are the angles, so let us consider alpha, beta and gamma are the angles with respect to x-axis, y-axis and z-axis. So cos alpha can be taken as L, so which implies alpha is equal to cos inverse of L. L is nothing but 2 by root 5. Similarly, beta is equal to cos inverse of 0. So cos inverse of 0 we can consider pi by 2, and gamma is equal to cos inverse of n. So here n is 1 by root 5. So here we can consider alpha, one angle is cos inverse of 2 by root 5, and another angle is pi by 2, and the third angle is cos inverse of 1 by root 5. So this is the answer. Given that two co-initial adjacent sides of the parallelogram are 2i minus 4j minus 5k, let us consider to be vector A, and another vector 2i plus 2j plus 3k, so let's consider this is vector B, and we need to find its diagonals and use them to find the area of the diagonal. So here let's consider the parallelogram. Let's say the adjacent sides are here the vectors A and the vector B. Then the diagonals can be considered to be A plus B vector. Vector A plus vector B is one diagonal. Let's consider to be vector C, and another diagonal vector A minus vector B. Let us consider vector D. So the diagonal 1 is vector A plus vector B, which is equal to 2i minus 4j minus 5k plus 2i plus 2j plus 3k, which is equal to 2 plus 2, that is 4i, minus 4 plus 2, that is minus 2j, minus 5 plus 3, that is minus 2k. Say this vector is C. And another diagonal D2, second diagonal, vector A minus vector B, which is equal to 2i minus 4j minus 5k minus 2i minus plus 2j plus 3k. On subtraction, so we get 2i minus 2i is 0, minus 4 minus 2 is minus 6j, and minus 5k minus 3k, that is minus 8k. So this is second diagonal. Let us consider to be as vector D. So the vector C and vector D are the diagonals, and using the diagonals we need to find the area of the parallelogram. So when diagonals are given C and D, so area of the parallelogram with the diagonal C and D as a vectors is given by half mod of C cross D, means half determinant of C cross D. So let's find the determinant of it. I, j, k, and C vector is having 4, minus 2 and minus 2, and D vector is having 0, minus 6 and minus 8. Let's find the determinant. So we can write I times of, this is 8 2s are 16, minus 6 2s are 12, minus j times of minus 32, and plus k times of minus 24, that is 16 minus 12, that is 4i, and this is plus 32j, and again here minus 24k. So we can write 1 by 2 the mod of 4I plus 32j minus 24k, or we can add 1 by 2 times. You can take 4 common outside, I plus 8j minus 6k. That is 4 upon 2 is 2 under root of 1 square plus 8 square minus 6 whole square. That is 2 under root of 1 plus 64 plus 36. That is 2 under root of 101 square units. So 2 root of 101 square units is the answer for this question.